All right, where we left off in the last session was try at number 6, using the order of operations to evaluate each of the following expressions, and we had gone through A through D, so we are on problem E now. And we had discussed, the P can stand for a grouping symbol, so we want to do what's in the brackets here before we do subtract by what's in the parentheses here. So we focus on this area, and we want to solve before we subtract the 4. We want to do this grouping symbol, 3 minus 8, this parentheses, what's in here first. So we'll go 3 minus 8 is negative 5. And then this is totally separate, so we can do this 3 minus 8 as well and get another negative 5, being really careful to keep everything in parentheses so that we keep our sign straight. And then now we can continue in this area and do negative 5 squared. And you want to be careful not to do too many things at once so you don't get confused. And then here we have a negative and another negative, so that's a plus 5. And now we can do our 25 minus 4 is 21. And the final answer is 26. All right, this next section here, using properties of real numbers, page 8 out of the textbook. For some activities, order doesn't matter. For others, order does matter. And these are other properties, kind of like PEMDAS is a rule of order. These are just properties. Some of them have to do with order, but they're just other general properties that or rules that you have to follow in algebra. So let's take a look at these. First one here is commutative. And this one is kind of saying the order doesn't matter. In addition, it's still going to be equal. And also for multiplication, if you change the order, they're still equal. So it's an addition, the addition property of the commutative property, additive and multiplicative. It works either way with the commutative property. And next is the associative. Property. And this one is you can move your parentheses around and it's still equal. So the order of the parentheses doesn't change the value. And it's similarly for multiplication. A times parentheses B times C is the same thing as A in parentheses times B times C. But notice this is all addition. This is all multiplication for this to be the same. If you start combining, then you got to be a little more careful. If you start combining multiplication and addition together, as the next property gets into, the distributive property. And you'll see this one a lot. So this is A times parentheses B plus C. And it's equal to the same thing as if you multiply A times each one of these separately, A times B, and add them together, plus A times C. And this is the main property that combines where you're adding and multiplying. The next one is the identity property. These last two are a little bit different. And this one is pretty straightforward. The additive identity is just 0. If you add 0 to any value, you're going to get the same number you started with. And then the same thing, similar with multiplication. If you multiply by 1, you get the same value you started with. And the last property is the inverse property. And this one, for addition, if you add the inverse, the additive inverse it's called, you get 0. And for multiplication, the multiplicative inverse is just 1 over the value. And if you multiply this together, you get 1. So here you have the additive inverse, and here you have the multiplicative inverse. And this second one here will show up a lot. All right, try it number 7. Use the properties of real numbers to rewrite and simplify each expression. So here is where you realize that you're multiplying. So think of this number here, negative 23 over 5 is A, and 11 is B, and negative 5 over 23 is C. And you have these parentheses and brackets, and it might be confusing, but the key is you're multiplying all these values together so you can change the order. So you can multiply this times this first, and if you recognize negative 23 over 5, negative 5 over 23 is the inverse of this first number. So if you multiply this number times this number, you get 1. So all you have left is 1 times 11 equals 11. And it's important to start recognizing these multiplicative inverses. It saves you a whole lot of time for instead of multiplying 23 over 5 times 11 and then times this. So the next one here, so following PEMDAS, you can add these two, 6.2 plus 0.4, and get 5 times 6.6. Multiplied together is 33. You can also practice your distributive property and multiply 5 times 6.2 and add it to 5 times 0.4. All right, let's look at C here. 18 minus 7 minus 15. And you want to do what's in parentheses first. So 18 minus 7 minus 15 is negative 8. And 18 minus a minus will be 18 plus 8 equals 26. If you did the distributive property to solve it, you have to be careful here and kind of assume this negative here is like a negative 1. So you do 18, and then negative 1 times 7 is a negative 7, and a negative 1 times negative 15 is a plus 15. And 18 minus 7 is 11, plus 15 gives you the same answer. All right, the next one here, the key is you're adding all of these together, all these numbers. And so once again, instead of A plus B plus C, you can add A and C together. It's an additive inverse. 17 over 18 minus 17 over 18 is 0. So all you have left is 4 over 9. And the last one here you know, you can do 6 times negative 3 is negative 18, plus 6 times 3 is 18, and get 0. Or you could do, let's see, it's good to recognize and know how to do this. You can solve it fine this way, but it's good to recognize that there's a 6 in the first part and a 6 in the last term here. So you can factor out a 6. It's kind of like doing the reverse of the distributive property. You can factor out a 6, put a parentheses, and then think to yourself, 6 times what gives you this first term? Well, it's just times negative 3. And then 6 times 3 will give you this second part. And that is equal to 6 times 0 equals 0. All right, let's take a look at the next section here, evaluating algebraic expressions. So the first one here, definition to fill in an algebraic expression is a collection of constants and variables. So we talked about a mathematical expression earlier, and those do not have variables, but that's the key with algebra. They will have variables with constants and then joined by operations. So what are the x and 5 in the expression x plus 5? Well, x is the variable, and 5 is the constant. So evaluating algebraic expressions is just determining its value. So if you have x plus 5, means you would be given a value for x like x equals 3, and then plug in 3 for x and solve x plus 5. So if x was 3, you'd put in 3 here for x. You get 3 plus 5 is equal to 8. So it's best just to start taking a look at some examples of all this. So try it number 8. List the constants and variables for each algebraic expression. So start with the constants. The constants here, values that are kind of predetermined, they don't vary, are 2 and pi, because pi is a specific value, 3.14, and then it keeps going on, but it's just a specific value. And then the variables are r and h. And then the constants in this second one are 2, and the variables are L and W, and then in this last problem, the constants, or the constant is 4, and the variable is y. And you could maybe think of the 3 as a constant, but not really. The 3 just means you multiply y together by itself 3 times. All right, let's look at a little more involved expressions here. So try it number 9. Evaluate the expression 11 minus 3y for each value for y. So you have 11 minus 3, and then you plug in the y value of 2. Get 11 minus 6 equals 5. Once again, you plug in the y value of 0 this time, and you get 11. 11 minus 3 times 0, this is just 0, so it's 11. And then 11 minus 3 times 2/3 equals 11 minus, and hopefully you notice that 3 times 2 over 3, you can just divide out these 3's here. 3 times divided by 3 is 1. And so you get 11 minus 2 equals 9. And 11 minus, 3. And y is -5. Notice we're starting out exactly the same. We put the parentheses around the number we're plugging in. Just once again, good to do it that way to keep everything straight. So fix my negative here. So 11 and then -3 times -5 is a positive 15. So you get 26. All right, try number 10. Evaluate each expression for the given values. So y plus 3 over y minus 3. Once again, you plug in y equals 5. You get 5 plus 3 over 5 minus 3 equals 8 over 2 equals 4. And b here, 7 minus 2t, plug in t equals -2, so that's 7 minus 2 times -2 equals 7 plus 4 equals 11. The next one here, 1/3 pi, and then you have r's 11, and that's squared. So plug that into your calculator. You'll get approximately 126.71. All right, the next one here, p squared, q in parentheses, and all of that cubed. So plugging in p is -2. You get -2 squared times 3 cubed equals -2 squared is 4 times 3 is 12, and that cubed equals, plugged it in my calculator earlier, 1728. The last one here, plugging in the fractions, you get, plugging in 2/3 for m, and n is 1/3 minus, plug in 1/3 first, minus 2/3. So this is equal to 4. 2/3 minus 1/3 is 1/3. And 1/3 minus 2/3 is -1/3. Being real careful to keep your signs correct. And then this is equal to 4 times 1/3 is just 4/3. And then a negative times a negative gives you a plus 5/3. Added together is 9/3, which is equal to 3. So far we're just kind of plugging in values for the variable and evaluating. All right, next section, formulas and equation is a mathematical statement indicating that two expressions are equal. So, for example, the equation 2x plus 1 equals 7 has the unique solution 3 because when we substitute 3 for x in the equation, we obtain the true statement 2 times 3 plus 1 equals 7. So let's look at the next statement here. A formula, which you use a lot in math and algebra, is an equation expressing a relationship between constant and variable quantities. For example, R, or the area A of a rectangle, in terms of the length and the width, is A equals L times W. So if you've got a grid like something like this, and 1, 2, put 3 lines this way, 1, 3 like this. So you basically have a length of 4. Let's say this is in feet, 4 feet times 4 feet. So the area would be 16 square feet. Area equals the length times the width. Another example, the area of a circle in terms of radius r is A equals pi r squared. So just showing how formulas, there are relationships between values. So if we doubled the length here, we would double the area. If we doubled the radius here, it'd be a little different relationship because you're squaring the area. So it would have even a bigger impact on the area if you doubled the radius. So let's look at an example here. Try it number 11. A photograph with length L and width W is placed in a mat of width 8 centimeters. The area of the mat is found to be A equals parentheses, and you can see the equation here, see the figure below, find the area of a mat for a photograph with length 32 centimeters and width 24 centimeters. Sometimes you'd have to set all this up for yourselves, but the problem actually had this written out for you, and you can tell my dimensions are not perfect the way I sized them, but important thing is just getting a picture if you don't have one in a word problem like this. So what the area of a mat, and like we said, we have the formula here. So it's just basically plugging in values here. A equals L is 32, W is 24, and once again, L is 32, W is 24. Multiply this out, or add first. 32 plus 16 gives you 48 times 40 minus 768 equals 1920 minus 768 equals 1152. And this was in centimeters, so this is, when you're doing area, it's centimeters squared. And you can kind of think through why this formula is correct, but it's basically taking the length, it's basically getting the area of this entire object and then subtracting out the middle area, and what's left will be the area around here, the mat. All right, let's take a look at the next section here. simplifying algebraic expressions. So using the properties of real numbers to make an expression easier to evaluate. So we have try it number 12 here. Simplify this expression. So here we can use our distributive property, -2 times the parentheses here. -2 times 4 over 3 gives you -8 over 3y. And then -2 times z gives you -2z. And so now you can combine like terms, the 2 over 3y and the -8 over 3y, get -6 over 3y minus 2z. You can't combine, if the variables are different, you can't combine the terms. So, and then you can divide -6 over 3 and get -2y minus 2z. Next problem here, where it's all addition slash subtraction, so you can combine these two terms which look alike. We'll just kind of put those two together and then put the other two terms together, and then you can see those are similar. So 5 over t minus 3 over t equals 2 over t. -2 plus 1 is -1. Here, once again, in problem C, you can distribute. So 4p times q is 4pq. 4p times -1 is -4p. Use the distributive property in the second part. You get q minus pq. And then start combining like terms. You have 4pq and minus pq. Put those together, and then you have -4 plus q left. You can combine these. 4 minus, this is 1pq, so you get 3pq minus 4p plus q. And they have to look exactly the same, so none of these are exactly the same, so you can't simplify any further. The last one here, you're going to start out by distributing again. Remember, if you have a negative, it's always good to just put a 1 there. If you have a negative and there's no number, just put a little 1 there. And -1 times s is -s. -1 times 2r is -2r plus. And there's nothing to distribute. If you put a 1 out front here, it would just be 6 minus s equals, combine like terms, put them together. And 9r minus 2r is 7r. And here's where you want to be careful. You might be tempted -s, so they cancel out, but no. A negative and a negative is -2s plus 6. And that's as much simplifying as you can do. All right, last problem here. Try it number 13. If the amount P is deposited into an account paying simple interest R for time T, the total value of the deposit A is given by A equals P plus P times R times T. Simplify the expression. So simplifying, I don't know, sometimes it's not always clear what they mean by simplifying, but what they're wanting you to do here is just, you can see a P is in the first term and the last term. It's just factored out kind of the reverse distributive property, and it equals to 1 plus RT, because if we multiply p times 1, we'd get p, and p times rt, we'd get prt. And it's just important to be able to, some of these math, finance, interest type problems, to be able to start recognizing it either way. So if you have money and you're getting simple interest on it, say you have $100 and you're getting 5% interest. 5% of 100 is $5. If you're getting that per year, you'd start out with your original $100 investment. 100 times 0.05 times 1 year would give you $5. If you did by two years, you get $10, 3 years, $15, and so on. And before we wrap this up, I thought it'd be good to look a little bit at a problem or two here. So the practice section really didn't cover a whole lot of like this section. For the following exercises, solve for the variable. And looking at number 33 here, we have negative 2x squared plus 1 equals negative 3. Let's take a look at that one. So negative 2x squared plus 1 equals 3. Is that what it was? Let's check. 2x all squared plus 1 equals negative 3. So change this to a negative 3. And to solve this, you square the 2 and the x, so you get negative 2 squared is 4, and then x squared is x squared, plus 1 equals negative 3. And then to solve for the x, we would subtract 1 from both sides, get negative 4x squared, plus 1 minus 1 is just 0, and then equals a negative 4. And then we are trying to isolate the x to figure out what it is, so we divide by negative 4 next, both sides, and we'd get x squared equals 1. And then one of the keys for picking out this problem here is when you solve for x squared equals 1, you take the square root of both sides. And when you do it, you do plus or minus, if I remember correctly. So you get x equals plus or minus 1.